Okay, good afternoon. Okay, so in the previous class we discussed a knapsack problem. Okay, so uh, so this is knapsack problem, and it is fractional knapsack problem. Okay, this fractional knapsack problem. Then in the previous class we studied the working of the knapsack problem. Okay, so okay, so now we want to discuss the algorithm. Okay, this is the algorithm for uh, greedy fractional knapsack. Okay, this is a greedy algorithm, and this is a university exam question. Okay, in the previous university exam, they asked one question. Uh, One question based on this topic. Okay, so explain fractional knapsack algorithm. In that way, they asked one question. So this is the algorithm for performing fractional knapsack problem or solving fractional knapsack problem. So uh, this algorithm is similar to we know the working now. This algorithm is similar to the working. Okay, so uh, how it will work? So there are objective, profit, and weight. We will find PA by WI. Okay, then there is a vector X, and how it will work? How it will work? First, find the object with the highest PA by W, okay, which is 8. Then check the capacity of the knapsack. Now initially the capacity is 15. So then check this weight. Weight corresponding to that object is less than the current capacity. Then we can include that object. Okay. Then and include it here full one. Okay, in this way it will work. I included I written here one because I included the full object. In this way it will work. When it will stop, when the capacity become greater than or the capacity becomes 0. So this is the algorithm for that. Initially I'm not explaining the working again, just we can go to the algorithm. Okay, so this is the algorithm for this. Okay. Initially we can note here we want to initialize X. What is X? You know, already know we studied what is X. This is X. Okay, it contains information about how much portion of the object is used. So if it is 1 means full object is used. If it is half means half amount of the object is taken, and so on. Okay. So there is a variable X. Okay, there is a variable X, and it initially what we will do? We will initialize that array to 0. Okay, for I equal to 1 to n, x of I is equal to 0. This is an initialization step. Okay, next is there is a w. What is this w? This w is the capacity of the knapsack. Okay, this is the original capacity. Okay, this is the original capacity of the knapsack. Okay, this is the original capacity. For example, it is 15 initially. It will be 15. So next what we will do? Initially it is, you can imagine in the previous case it is 15. Okay, 15 is the weight. Here C is equal to 50. So here C is equal to 50. So I told this process is repeated how many times? Basic process is this one, this and so on. This will repeated how many times? That is weight less than W. Until weight less than W, this there is a for loop, which is the for loop. This is the, there is a loop. This is the loop. This loop is executed. Okay, this is the body of the loop, and the body of the loop is executed until weight less than W. Okay, so here W is the capacity, which is always constant. Okay, and weight is a variable, it changes. Okay, so while weight less than W, this loop get executed. Okay, so next we want to focus on this loop. Okay, we want to focus on this loop. This is the loop body. Okay, so first what we will do, you can just observe here. So first we will select an object here, Pi by Wi, the largest object with Pi by Wi. Similarly, here what we will do, here best remaining item. Okay, we are writing in this way. Okay, so select the next best remaining item from the object based on some selection criteria. Okay, based on some selection criteria, select the best. Based on some selection criteria, select the you can note this step. This step means based on some selection criteria, select the best object. Okay, best remaining object. Okay, so we are using that technique here. That is here Pi by, this one is the best object because Pi by Wi is highest. Then the corresponding object is basically 5. O5. We will select the object O5. O5. Okay. Then this is the weight of that object. Okay. Then what we will do next? Next we will check this condition. Okay. Next we will check if weight plus W, the weight of the weight. What is weight means? Weight means it's a variable. It is initialized to 0. Okay, initially it is 0. It will increase during each iteration. Okay, so next we will check this condition. If weight plus W of I, what is W of I? Weight of the selected object. Okay, weight of the selected object. Okay, this is W of I. W of I means weight of the selected object. If weight plus W of I less than or equal to W. Okay, for example, this is the situation. Okay, that is, we selected object 5, then weight of that object is 1. 1 less than 15. Okay, 1 less than 15. Then we can, what we can do, we can include that object fully in this list. Okay, that we want to do. That is, then one more. Sorry, disturbance ഉണ്ടോ? മഴ പെയ്യുന്നുണ്ട്, അതുകൊണ്ട് ചോദിച്ചു. ഹലോ, സംഗീത്, നിതിൻ ബാബു, any disturbance? Okay, wait. Okay. Okay. So, weight plus W less than or equal to W, then what we can do? We can set x of I is equal to 1. Okay. We can set x of I is equal to 1, which means if this condition is satisfied, we can include that object fully into the knapsack or bag. Then set x of I is equal to 1. Okay. So here we are putting 1. Why? Because we can include that object fully into the bag. Okay. So after that, what we will do? We will update the weight variable. Okay. We will update weight, this variable. Okay. We will update weight variable. Weight is equal to weight plus W of I. Okay. So we will update the weight. That is, we included one object, then we will update the weight. Basically, this is the concept. Initially, this is the capacity C. There is a variable weight. Okay. This is 15. It is fixed. Then what we will do? Here there is a variable weight. Okay. Here there is a variable weight, and we will update this variable continuously until we will update this until it reaches W. Okay. So that is weight. Weight is equal to weight plus W of I. Okay. Weight is equal to weight plus W of I. That is, we will include the object into the list and we will update weight variable. Weight is equal to weight plus W of I. What is W of I? Weight of that object, included object. Weight of that object. Okay. For example, weight of that object I. Okay. Weight of the object I is W. Okay. In this way, we will update the weight. Object I. Weight of object I. Okay. Yeah. Weight of object I. Then, if next this process is repeated. Okay. This is if this condition is satisfied, then this part is executed. Then again, what we will do? We will update the weight to W. Okay, sorry. Weight is equal to this. Then we will go back here. Okay. In this way, the loop is repeated. So This is the concept. Okay, so we included this one full here. Then we will select the next one. Okay, we will select the next. Which one we will select it? 1 point, sorry, 5 we will select. Okay, then weight of 5 is still 1. Okay, this is object 1 and weight W is 1. Okay, W is 1. 1 less than the current capacity. Okay, 1 less than, then it will check 1 plus 1 plus 1, 2 less than capacity, then 2 less than capacity, so include full weight. Then we will take the next object and so on we will proceed. Anyway, so this is the code for that. If weight plus W of I less than or equal to W, then X of I is equal to 1, then weight is equal to weight plus W. Else, okay, else means fractional case. Okay, then if this case is not satisfied, what we will do? This case is not satisfied, then what we will do? This case is not satisfied, then naturally the else part is executed. In the else part, we will calculate how much portion of the object should be included. That is based on this equation. X of I is equal to W minus weight divided by Wi. Okay, so then what we will do? Then we will update the weight variable. Okay, so this is the fractional case. So this is the fractional case. Okay, fractional case. This is fractional case. Okay, this is fractional case. So in this way, this will work. Okay, this process is repeated how many times? Until weight less than W. Okay, so this is the working of the knapsack. This is the algorithm for fractional knapsack, and this is a university exam question, so please study well this topic. Okay, so we discussed knapsack problem, and we discussed knapsack problem, how to solve the knapsack problem, then the algorithm also discussed. Okay, I'll repeat it one more time, just the algorithm. Okay. So you can note here, initially we will initialize x all to 0, X of I is equal to 0. Then we will initialize a weight variable which is 0. W is the capacity of the knapsack. Then what we will do? We will do a while loop until weight less than W. Okay, so if weight less than W, what we will do? We will select the best remaining item based on some selection criteria. Okay, one selection criteria is this, that is select the object with the largest PI by WI. There are some other selection criteria also. Okay, so based on some selection criteria, we will select the best object, best remaining item from the list. Okay, let it be I. Okay, next what we will do? If weight plus W of I less than or equal to W, we will check this condition. If this condition is true, which means we can include that object fully into the knapsack, then we will update X of I is equal to 1. Okay, like this. Okay, we will update this to 1. Okay, that is, we will include that object fully into the knapsack. Then we will update the weight. Weight is equal to weight plus W of I. Okay, so else, in the else part, else means fractional case. Okay, this is fractional case. Okay, this is fractional case. If we can include only part of that object, then we will calculate how much portion of the object can be included using this equation, W minus weight divided by W of I. Then we will set x of I is equal to that. That is x of I is equal to W minus weight divided by W of I. Then we will update the weight variable here also like this. Here weight is equal to weight plus Wi. Here weight is equal to W. So this is repeated until how many times? While weight less than W. Okay. So in this way it will work. Okay. So this is fractional knapsack problem and its work. Okay. So you can observe that in our this is the fifth module we are discussing. Okay, in the fifth module the first part we will study greedy approach. Okay, the first part greedy approach we studied. So what is greedy approach we studied, then fractional knapsack problem we discussed. Okay, algorithm discussed, method discussed, what is the definition also discussed. Okay, these are all university exam questions. Okay, please note it and study well. You can expect, surely you can expect 10 mark from this section. Okay. So also we discussed what is 0/1 knapsack problem. Okay, in the syllabus only fractional knapsack problem they are mentioning. Sometimes they may ask the question of 0/1 knapsack problem also. Already we discussed that topic. Okay. So next, so now we are discussing which approach? Now we are discussing greedy approach. Okay, now we are discussing greedy approach. So, another two concepts are we already studied. Okay, while discussing the third module, we studied minimum spanning tree concept. In the previous exam, series exam also, you may studied that topic. Okay, that is what is minimum spanning tree and which are the algorithms used to find the minimum spanning tree. Yeah, wait. Disturbance in the ഇന്ന് ആരും ഒന്ന് റെസ്പോണ്ട് ചെയ്ത് ഇവിടെ നല്ല മഴയാണ്. എന്തെങ്കിലും ഡിസ്റ്റർബൻസ് ഉണ്ടോ? സഹല, വിഷ്ണുവിനോ? വിഷ്ണു വിഷ്ണു ഒന്ന് വെയിറ്റ് ചെയ്യട്ടെ, മഴയില്ലാണ്ട്. ഓക്കെ, എനിവേ next we want to discuss two concepts. We want to discuss minimum spanning tree concept. Okay, we already discussed what is minimum spanning tree, which are the different algorithms we can use. Which are the different algorithms we can use? We can use PRIMS algorithm or KRUSKAL algorithm. Okay, we already did that concept. The same we want to apply here. Okay. And the third module, we taken that in detail. Okay. What is PRIMS algorithm? What is it, how it's work? Similarly, what is KRUSKAL algorithm? What is it, how it works? And what is minimum spanning tree? And which are the algorithms used? These all topics we discussed in the third module. Okay. So, in the fifth module, while studying the greedy approach, we need to study the same topic. Okay. Okay. So, third module, same topic is in the fifth module. I mean, already I taken at that time during the revision, while discussing third module, we already discussed and PRIMS algorithms. Okay, so you can just your university exams also. Okay, in the university exam question paper also, problems coming from this fifth module. For example, you will given with a graph, then perform PRIMS, then perform KRUSKAL algorithm. That type of questions coming from the module. Okay, not from the third module. Okay, just go refer some previous year university question paper, then you can obtain. Okay, that is uh, problems based on Pascal Prime's algorithm is asking from the fifth module. That already we studied. Okay, so we don't want to worry, and the concept we need to apply. Okay, so in this module, in this fifth module, these are the topics we want to study. Okay. Okay, anyway, I'm just moving to the Pascal, just refreshing the Pascal algorithm. Okay. So this is minimum spanning tree. Okay. What is minimum spanning? What is a minimum spanning tree? A minimum spanning tree or minimum weight tree is a subset of the edges of the connected edge-weighted directed graph that connects all the vertices together without any cycles and with the minimum possible total weight. Okay, total weight. That is a spanning tree whose sum of edge weights is small as possible. This is the definition of spanning tree. Okay, minimum spanning tree. Definition of minimum spanning tree. Okay. Then, for example, this is a minimum spanning tree. Okay, there is a graph. Then this edge, this edge, this edge, this edge, this edge, this edge. Okay. So all the vertices are visited. Okay, all the vertices are visited here, but we didn't use all edges. Okay, we used a subset of the edges only, and we visited all vertices with the minimum cost. Okay, that is minimum spanning tree. Please study this. Next, this is the Pascal algorithm we studied. Okay. Basically, this Pascal algorithm is a which type of algorithm? Greedy algorithm. Okay. This Pascal algorithm is basically a greedy algorithm. Okay, we studied this algorithm, no problem. This algorithm uses greedy approach. At that time, we are not aware of that, but this Pascal algorithm will use the greedy. Okay, so this is the algorithm for this. What we are doing here, you can note it is a graph. But first we will find out the edges and sort it in the ascending order of the weight. Okay, a very simple example actually. This is the algorithm. Initially, A is equal to empty. For each vertex we will make set V. Then sort the edges. Okay, sort the edges G dot E into non-decreasing order by weight. What we will do for each edge UV G dot T taken in non-decreasing order by weight, we will add it to A. Okay, add it to A. In this way it will work. So this is a great algorithm basically. So you should study this algorithm. I think already you exam. Okay. So this is the working. Initially, I will select the minimum weighted edge 1, then the second minimum 1 2, then this one 1, 2, then 3. Then we will select this one. In this way it will proceed. Okay, I'm not the working again here. Okay, so that is here what we will do. We will select this. Next is here 4 is there. Here 4 is there. Okay, so we will select this and add it to the graph. So we go to 1, 2, this. Okay. Next what we will do, we will select the next minimum energy. Okay. Which one was? Okay. So this one. We will select this one. So this that will not form a cycle. Okay. That should not form a cycle. Then only we can add. So uh, this one. Next what we will do, 4. After 4, 6 is there. Okay, 6. But if we selected added, this will form a loop. So we can't select this. Okay. We can't select this. Okay. Next, what we will do, we will select this one, 7. It's a simple algorithm. Please do it yourself. Okay. So this is the algorithm for this. We will first sort the edges in ascending order. We will select an edge and add it to the graph. If it does not form a cycle, then that process is repeated. That is, that process is repeated for all edges. Okay, so very simple algorithm. From this algorithm, usually university exam, they may ask questions. Okay. Given a graph, perform KRUSKAL algorithm. So it is a greedy approach-based algorithm. So next we studied about the PRIMS algorithm. This also we discussed in the third module. Okay. This is also which type of this is also a greedy approach based algorithm. Okay. Minimum spanning tree using PRIMS algorithm. So PRIMS algorithm also is greedy approach. Okay. Now we studied this topic also. Okay. Algorithm, and this is the working. I studied that in the third module. Same concept we need to apply in the fifth module. Okay. So basically these two algorithms, prime and KRUSKAL, are greedy approach based algorithm. Okay. University exams you can analyze, and the university exams problems based on the PRIMS and KRUSKAL always comes from the fifth module, not from the third module. Okay. So please note that anyway we discussed that. Okay. So we discussed the facts and problem also. Okay. So anyway we can discuss the next topic, the next class. Okay. Please give your please give your attendance. Wait. Please give your attendance. Wait. Akash. Akash. Okay. Next. Akash. One. Okay. Akash. Opinel. 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 Absent. Chat box ലിട്ടെ ഫാസ്റ്റ് ആയിട്ട് ഇട്ടു. അദ്വൈത് അഭിനന്ദ് ആബ്സെന്റ്, അദ്വൈത് അജ്മൽ അഖിൽ സി പോള് അനക്ക് അനുഗ്രഹ് ആദർശ് അഞ്ജലി അതിൻ 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 ആബ്സെന്റ് ആണോ? അതിൻ. ഓക്കെ നെക്സ്റ്റ്. ദിൽന. നെക്സ്റ്റ് ദേവിക. ദേവിക ആബ്സെന്റ് ആണോ? ദേവിക. ദേവിക. ഓക്കെ, നെക്സ്റ്റ്. നെക്സ്റ്റ് ദേവിക കഴിഞ്ഞവരാണ്? ചാറ്റ് ബോക്സിൽ അറ്റൻഡൻസ് ഇട്ട് ജസ്റ്റ് മസ്ന. ഓക്കെ. മുഹമ്മദ് സിനാൻ. ഓക്കെ. മുഹമ്മദ് ഇജാസ്. ഇജാസോ? കാർത്തിക് കീർത്തന ആബ്സെന്റ് അല്ലേ? കാർത്തിക് കീർത്തനൊക്കെ. കാർത്തിക് പ്രസന്റ് ആണ്. കീർത്തന. ഓക്കെ. നേഹ. ഓക്കെ. നിതിൻ ബാബു. നെക്സ്റ്റ് പ്രണവ് സി. പ്രണവ് എ. പ്രണവ്. റൈസ ഖാലിദ്. റസാന നിഹാല. റസാന പ്രസന്റ്. നെക്സ്റ്റ് റോഷൻ. ഓക്കെ. ഓക്കെ. നെക്സ്റ്റ് സഹല ബി. സഹല ബി. ഓക്കെ. നെക്സ്റ്റ് സംഗീത് സാരംഗ്. ശ്രദ്ധ. സംഗീത ആബ്സെന്റ്. സംഗീത് ഷാറൂൺ.
ഷാറൂണിന്റെ നെറ്റ് പോയി.
ഓക്കെ. ശ്രദ്ധ. വിഷ്ണു. വൈഷ്ണവി. വിഷ്ണു. ഓക്കെ. അഞ്ജിത. ഓക്കെ, താങ്ക് യു. അപ്പോൾ ഫിഫ്ത്ത് മോഡ്യൂള് നെക്സ്റ്റ് അടുത്ത ക്ലാസ് ഡിസ്കസ് ചെയ്യാൻ പറ്റും. ഓക്കെ.